going on, everybody? It's Mr. Gustin. I'm back in the physics classroom. Now we are in Unit 8. We've moved on from rotation. We are studying simple harmonic oscillators, and we are going to begin our study with a pendulum. Today we're looking at what a pendulum is, some factors that we can change with a pendulum, and we're studying how these factors affect the rate at which a pendulum swings. We think back to Unit 3, which was circular motion. In circular motion, we were dealing with oftentimes simple harmonic oscillators, things that moved in a circle at a constant speed. They were simple harmonic oscillators. They followed some interesting patterns. And in this unit, we're going to kind of reprise those patterns and study a few different oscillators. Today, though, it's the pendulum. And we are studying three factors. So first of all, maybe we don't know what a pendulum is. Let's look at a pendulum. I've got one set up over here in the classroom. I've got the monkey bars and table clamp. We can see it up here. What's so interesting about this pendulum is that it looks very similar to a rotating object. There is, in fact, an axis of rotation up here. There's a radius, and then there's a point mass dangling down here. And the way a pendulum works is we pull it back away from equilibrium. We would call this position equilibrium. Equilibrium is a position where there's no acceleration taking place. If I graph the forces that were here on a FBD, I'd say there was a tension force supporting it. Gravity pulls it down. So when it's at this location, we'd say it's in equilibrium. We would call this position its equilibrium position. So we displace this thing from equilibrium by a certain angle or amplitude. We change it to say, let's say, 5-degree amplitude and let it go. And as this object swings back and forth, this is what's known as simple harmonic oscillation. It is going back and forth in a very repeating pattern, a very predictable pattern based on its displacement from equilibrium, based on its amplitude. So there are a couple things that we can study, a couple things that we can examine. I wonder if I'm questioning what this object or how this oscillation takes place, how these patterns take place, there are a few things I can change and I can study. The first thing is I wonder how changing the amplitude of this pendulum dictates its repeating pattern. It dictates its motion, dictates the frequency of its motion. I wonder how changing the mass, if I go ahead and take, this is a 200-gram mass, if I take a different mass, I wonder if a heavier mass would cause this thing to accelerate faster or slower, cause its frequency to increase or decrease. The last thing I'm curious about is the length of this pendulum. This is a very long pendulum, but what if I went ahead and I shrunk the length to, say 1/2? Would it move faster, slower, the same length? I don't exactly know. So these are all things that we can study, and these are all experiments that we're going to design today in class, carry out, gather some data on so we can learn more about the pendulum and its simple harmonic motion. So first things first, we're going to conduct three experiments, the length, the mass, and the amplitude experiment. Your job at home or in the classroom is going to be to take the time data. I will give you the length, mass, and amplitude data. You take the time data. Then we'll graph this thing, and the idea here is that we're going to figure out how these variables, how these physical variables impact the period or the oscillatory motion of this pendulum. That's our plan today. So I should be having three experiments, one for length, one for mass, one for amplitude, and I should go ahead and make sure that I have those data tables set up, and I'm prepared to analyze these things graphically. Not just, it changes, it doesn't change. I need to know specifically what is the graphical and mathematical relationships for length, mass, and amplitude of a pendulum. First things first, let's do length. I'm going to try my best to get as many lengths as possible here. And let me get an angle of a protractor so I can make sure we hold amplitude constant. There's a protractor. So while I am testing length, I need to make sure I hold amplitude constant and hold mass constant. This allows me to make sure any changes in period are only because of the length of the pendulum, okay? So I'm going to try to displace this thing by a displacement of like 5 degrees every time or 10 degrees every time. No, we'll go, let's see if I go out to there. Like 20 degrees. Out here is 20 degrees. No problems. We'll stay out here, and I can make a mark on the table here with the protractor that will tell me it's always going to be right there. Okay? So first things first, let's use this length. This length of the pendulum, we're always measuring from the axis of rotation down to the middle of the mass. That's how we can do this. This is a 95. This is 95 centimeters, 95 centimeters, okay? I'm going to displace it back to this position. When I say go, you're going to time 5 swings. 5 swings, that way we can divide by 5, figure out the period. So 5 swings, 95 centimeters, 5 swings, 3, 2, 1, go. That's got to be 5 at that point. That's got to be 5, okay? Now we're going to start wrapping this thing up. So instead of shortening or tying a new string, I'm just going to go ahead and try to wrap this thing around and see if that allows me. That's pretty good. All right, so I've wrapped it around. Now I know I can now I know it's shortened. Let's take a new measurement from the axis of rotation to the middle. This is going to be 80 centimeters. 80 centimeters, you've got 5 swings. Are you ready? Go. Hopefully that was 5. Let's go to experiment number 3. Trial number 3, measurement number 3. We're going to wind this thing up. One more time. Let's see where we're at now. This is the third experiment, or the third, I keep saying experiment, this is the third measurement. Third measurement. Axis of rotation, down to here. We're looking at 64. 64 centimeters. Ready? Go. All right, wrap it up again. 1, 2, 3, 4. Got to make sure as I do this, I want to make sure I'm still going to about 20. There we go. 3, 2, 1, go. All right, let's see. Actually, I didn't get the measurement, did I? 46. That's 46. All right, 46. It's 1, 2, 3, 4. Let's see if we can't get another measurement out of here, or 2, before this thing gets too short. All right. This is 28 centimeters, 28 centimeters. Ready? 3, 2, 1, go. All right, 28 centimeters. And we'll go with one more. We'll see if we can get this thing inside 20. Oh, super tiny, super tiny. Little itty bitty pendulum. I'm going to go to 15. 15 centimeters. You ready? Go. That was 5 at 15 centimeters. All right, so that's that. First experiment done. I've got my data on the board. You should have that data recorded now as well. There's some calculation you'll have to do, and that calculation is going to be dividing 5 swings by total time to figure out the period of this motion. And the period of this motion is simply how long it takes for one rotation to take place. But we know that from previous units, and that's what you're looking for is the period here, okay? Now, with our next experiment, we're going to have to test mass. So we've tested length. Length is over here. I've got my lengths on the board. You should have the time for those 5 swings for each of those lengths. But now we're going to test mass. To test mass, I want to keep length constant and amplitude constant, but I want to go ahead and change the mass every time, see how mass impacts the rate of this swing. So time to do that. We're going to start small with little masses and work our way up to big masses, and we're going to do something very similar. 5 swings, divide that time by 5 to find the period of the swing. All right, so our length of this pendulum is the original length, which is 95 centimeters. That might be useful to you. We are going to start with 20 grams. I have my mark on the table still for amplitude. I can still do this. This is 20 grams or 0.02 grams, kilograms. Ready? 3, 2, 1. Let's make sure we're far away. I don't want to hit that thing. 3, 2, 1, go. It's 1, 2, 3, 4, and 5. 20 grams. That was 20 grams. Let's go ahead and do 50 grams. 20 grams, 50 grams. 3, 2, 1, go. All right, hopefully we're done there. Wasn't even paying attention to it. I'm writing the data on the board. That was 50 grams. Now we're up to a 100-gram mass. Ready? 3, 2, 1, go. We're going to do 100, 200, 500, and a kilogram. The big dog. There we go. That was 5, or if not, it was 6. That was 100 grams. We've done 20 grams, 50 grams, 100 grams. Now we're up to 200 grams. And we're looking for 5 swings. 3, 2, 1, go. That's 1. There's 2, 3, 4, and 5. Wonderful, wonderful, wonderful. That's 200. Now we're going to 500 grams. We're making sure we get a large collection or a large smattering of data. We want a large set of data, not numbers that are so close. We want them spread out because then I can see how it changes over how period changes over drastic changes in my independent variable. All right, I'm going to actually hold this bar still because it does tend to move quite a bit with heavier masses. So here we go. Ready? 1, 2, 3, 4, and stop. There it is. Make sure you wait for it to come to a stop. Now I've got the heavy one. I've got the 1 kilogram mass, the 1,000-gram mass here. I really am going to have to make sure I hold this bar in place because it's going to want to move, okay? So we're going to start here. 3, 2, 1, go. And let's just make sure we have enough to get it. And we got it. Perfect. All right. So now I've got this data on the board as well. We just finished our mass experiment. There it is. We went from 20 to 50 to 100, 200, 500, and 1 kilogram. We've spread out our data over all of these masses. That's fantastic. The last thing we have to change is our amplitude. We want to study the amplitude, okay? So we're going to go from varying degrees, right? Various angles of displacement to see how that impacts the rate of this swing or the oscillatory frequency, if you will. So we got to pick our favorite mass. I need to keep length constant. I need to keep mass constant. So I want to find my favorite mass. I was a big fan of the 200-gram mass. It's heavy. It gives some tension in the string. I don't know. I'm not sure it matters. You'll tell me once you analyze the data. But I want to go ahead and use this mass just because I like the way it looks and feels on the string. Why? I don't know. I just do. Lay off me, dude. All right? So let's do that. Using the protractor to tell me the different amplitudes. I'm going to start pretty small. This protractor is weird. It's like you can see through it, which is nice. But I'm going to go ahead and probably just displace this thing 5 degrees every time. So we'll start with 5, 10, 15, 20, 25. 5, 10, 15, 20. That's 5 data points. That's going to be enough for us, I think. All right? So let's start here. I've got my string down here at 90. Let's go ahead and the hardest part about this is almost a 2-person job here is to go ahead and pull this thing 5 degrees back right here. Ready? 3, 2, 1, go. 2, 3, 4, right, that was it. That was 5 degrees. That's a little amplitude. It's not a very big amplitude. It's pretty small, but hopefully you're able to see it once it comes to a stop on one side. It's like, that's one swing. Let's go ahead and do a 10 degree amplitude. 5, 10. There it is. Ready? 3, 2, 1, go. 2, 3, 4, and 5. Last one, not the last one. Let's do 15 degrees. 15 degrees. There's 90, get to 15. There's 15 degrees. 3, 2, 1, and go. Dropping my protractor. All right, I got 5. If not, divided by 4. I'm getting restless. It was 15, let's go to 20. Make sure, there it is. I'm starting at 90, I'm pulling back to 70. Go. I notice it's swinging faster. It's definitely swinging faster. It's covering more ground, but it definitely is swinging faster. That's interesting. All right, that was 20. Last one, I'm going to pull back all the way to 75 degrees to set this thing up for its 25-degree amplitude. All the way back over here. And go. It's definitely faster. I can see it visually moving faster, but I don't know if that means it makes it swing any faster. I don't know. And we're good there. Okay, perfect. I have just tested amplitude. So amplitude we tested at 5 degrees, 10 degrees, 15 degrees, 20 degrees, and 25 degrees. We tested these things. So now, in your data tables, maybe you haven't made data tables yet, but you do. You need 3 data tables for 3 various experiments. We're testing the simple harmonic oscillatory motion of the pendulum with length, mass, and amplitude as independent variables. We've tested these things. I need you to graph these things and analyze to determine, are these things factors that affect the rate of oscillation, otherwise known as the frequency, sometimes known as the period. Your job is to figure this out. It's just the lab. Tell me what it is. If you have questions on the data analysis, drop in the comments, send me an email, or as always, ask me in class. But I'm curious to figure out what you have. Until next time, see ya!